Hi, this is Bryan.D with my AI Project 1. This is my main loop. I just use it to create an interface screen and call screen.start. My interface is a loop that counts all of the options and the interface, and it takes in the arrays that you want to use. You can select either easy, medium, or hard, or you can create a custom loop. You can then select your method for searching, and then it uses switch statements to call the method. In the solver class. This is the solver class. The solver class has all of the search methods in it, a destroyed node method, and a print method. For breadth first search, I use a hash map of int and bool to measure the used and a list of node pointers for my queue. If a node's state value has already been found or in an earlier depth, then it doesn't push it onto the queue. If not, then it pushes a used marker onto used and pushes back the queue. To get the children, I call pointer.children, which is node children, and this is my node class. Node class takes in values for the start and sets the array value and the Manhattan distance and such as. All of the nodes besides the start node are created in this children method. This children method, I use an array and I use a switch statement, and based on where the 0 is, I write out the different options for the switching, and I put them into a vector kids in the node. I create new nodes, push them into the vector, and then continue on to the next one, and then I break. I do this for all of where the 0 could be and just switch where the node's current state values are and put them into the new node. I don't actually switch the actual values in the node. And then I go back to solver and pointer less than kids.size, and I loop through all the kids. Okay, depth first search is a little different than breadth first search. I do not use an actual queue. I instead use a recursive-esque method of just using the parent-child relationship to loop through all of the children, and once I hit the maximum depth or I hit a state value that's already been used in one of the parents, I destroy the node and go back up to the parent and visit the next child. UCS, best first search, and A*1 and A*2 are all identical code except for this little struct right here, which is a compare operator for my priority queue. I use a priority queue for all of these methods so that I can keep them organized, and a hash map of int and node pointers for used. I do this so that I can check if the node's been visited and it's unused, then I don't push the child onto the queue. If the node has not been visited and the kid's total cost is less than the other total cost, then it sets the other total cost to true, or the others visited to true, and goes into the queue. It pushes it onto the queue. I set the parent's total cost to true, or I set the old's total cost to true because I have this if statement that if its total cost is true, not total cost is true, if it's visited is true, sorry, I'm trying to finish this in 5 minutes. If visited is true, it skips all this, pops the top, and goes to the next node. So let's run the code. I appear to already be running the code. Okay, so here is the output. We'll go ahead and do it again. I'll go 3 and A*2. All of the methods work completely. A*1 and uniform cost search take over 5 minutes, but everything else finishes below 5 minutes. As you can see, it prints off the board and what you need to do to get to this board, the cost of the move, and the total cost at that point. Then at the bottom, prints off the length, cost, time, and space. And then you type in anything to go again. This has been AI Project 1. Thank you.